Hi, how's it going? Welcome to Code with Z. In today's video, we have to invert this binary tree. Why? Well, because that's what LeetCode 226 Invert Binary Tree is asking us to do. As you can see, it says, given the root of a binary tree, invert the tree and return its root. Okay, let's see how we can solve this. So if we want to invert this, let me first bring this here. If we want to invert this, we have to turn this into this tree that we have here. As you can see, the roots are the same, so 4 and 4, but then we've swapped this with this one over here. So as you can see, instead of 2 and 7, we have 7 and 2. And then we also have to swap these. So instead of 1 and 3, we have 3 and 1. And instead of 6 and 9, we have 9 and 6, like so. So we basically just have to invert this. And inverting is just basically replacing what is on the left side with what is on the right side. Okay, let's see how we can solve this. So because this is basically like swapping, I want to give a swapping example if we have X and Y. So most of us know how to actually swap these two, and our approach is going to be really similar, but we're just going to do it with a tree. So if we wanted to swap the values between X and Y, we're just going to say we're going to have a temp variable, and this temp variable is going to have the value inside X. So temp is going to be equal to 2. And then we're going to say, now that we have the value of X stored somewhere, we're just going to say X should be equal to Y. And then we're going to say Y should be equal to temp. And this is going to be basically it. Now X is equal to 5 and Y is equal to 2. And as you can see, we have swapped their values. Now with our tree, we're going to have something really similar. So this is going to be our root. And we're going to have the same thing. We're going to say, we're going to have a variable called temp. And this is going to store the values that we have on the left side of our root. So basically, this is the root, and we're going to say temp is equal to root dot left. So anything on the left side of our root. And then we're going to say, okay, now that we have the values on the left side, let's swap these with each other. We're going to say the value on the left side should be equal to the value of the right side, like so. So we basically did this. Now we have the right side. Previously, we had this. And now we have this, because we just said left side should be equal to the right side. So now we have the values on the right side in our left side. But because we have stored the values we had on the left side in temp, we're going to say right side should be equal to temp, like so. Now we've actually swapped it. We just swapped these with these, as you can see. And we're done for this round. Now that we've actually swapped these, we want to call this function again for each one of these roots, so we can actually swap everything that we have here and everything that we have here with each other. So we're just gonna call the same function for these two this time. And the first time we called it for this one, this was our root, and now this time these are our roots, and we're gonna call this function on each one individually. For example, for this one we're gonna say you are the root, so 7 is gonna be root, and then we want to swap the values that we have on the left side with the right side. So we're going to swap 6 with 9. And now we have 9 and 6. And then for this one, we're going to say, you are the root. And then we want to swap the values on the left side with the right side. So now we're going to go from 1 and 3 to 3 and 1. Simple as that. And now this round is done as well. And then this time we're going to call the same function for all of these here, like so. Because if they had children and nodes of their own, we want to make sure that we swap the nodes. So we're going to say, swap anything on your left with your right, swap anything on your left with your right, swap anything on your left with your right, swap anything on your left with your right. But as you can see, there's nothing on their left side or their right side. So we're just going to keep them as they are. And now we're done. If we actually check, we've inverted our tree. In the beginning, we had this, and now we have this, just like we saw in the first slide. Now that we have this, and now that we've actually inverted our tree, we're just going to return our root, and that's going to be it. Now, let's code this in the simplest way possible. Alrighty, let's code this together. So the first thing that we need to have is going to be our temp variable, just like we saw in the slides, and this is going to be equal to root.left. Then below this, we're going to say root.left is equal to root.right. And then below this, we're going to say root.right is equal to temp, just like we saw in the slides. And then we're going to call the same function for the left side and the right side. Our function is invert tree. So invert tree, and we're going to call it for the left side, and we're going to have it one more time for the right side. So we're basically calling it for the left side and the right side. And then at the end, we're going to return the root, just like we saw in the slides. But we need to make sure that when our root is equal to null, we're going to return null. Why do we need this? Well, for example, once we reach this stage and once we call this function for the right side and the left side of this node, and we know there are no children, we don't want to get stuck with null. So we're just going to say if the root does not exist, return null. And that's going to be it. Now let's run this and see if we can actually get accepted. Moment of truth. And yep, we got accepted. Now let's submit this and see if we can actually pass all of the test cases. Let's see. And we got accepted. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.